Hello everyone, welcome to Prestige Academy's online lessons. This is Algebra 1, Class 4. Today we're going to be going over inequalities, domain and range, graphing inequalities, and lastly, system of equations. Let's get into inequalities. These are the 4 signs we need to know. This is going to mean greater than, this is going to mean less than, this is greater than or equal to, and this is less than or equal to. So, let's give an example for greater than first. If we say x is greater than 5, x can be anything larger than 5, 6, 7, 8, 9, but it can't be 5 because it doesn't have the line under it that means equal to. So how do we put this on the number line? We first have to find 5. Let's say this is 5. If it's greater than or less than, we are presented with an open circle. If it is greater than or equal to or less than or equal to, we're presented by a filled in circle. So this 2 is going to be this 2 is going to be this. So because our question doesn't have the line under it, that means or equal to, it is just greater than, so we have to use this one. So we put an open circle on 5, and then we look at the sign. This is greater than, so we are going this way. Because as you go right, as you remember from the first class, the number gets bigger. And to remember this, you can just look at the sign. The sign looks like an arrow that's going this way, so just make the arrow go this way. Let's do an example for less than. X is less than 3. We just draw the number line. Find 3. Let's say it's here. Because it doesn't have a line under it, it's going to be an open circle. And because it is less than, it's going to go this way. Now let's graph greater than or equal to. And our example can be x is greater than or equal to 6. And we just do it the exact same way we did the previous 2 questions. But in this case, we're going to use filled in a full circle, like this. And because it is greater than, we're going this way. And lastly, let's do an example for this one, but I want to write this a different way. Now, let's say 3. This is going to mean the same thing as why does it mean the same thing? This is saying that x is less than 3. So x can be 2, 1, maybe 0, -1, any number that is less than 3. And this means 3 is bigger than x. So x needs to be smaller than 3, which again, 2, 1, 0, -1, any number in between. So these two are the same thing. So let's say the question gives us this. 3 is greater than or equal to x. Now the easy way to do this is to move x this way and say, just convert it back to this form. Let's put x here, flip the sign, don't forget the line, 3, and then just graph this. Let's get rid of this. You put the number line in, find 3. Let's say it's here. Because it has the line under it, it's going to be full circle and draw the line. Now, if our question says, for example, x is greater than 5 and asks us if 4 is a solution, there are several ways we can do this. We can plug 4 in as x. When we do that, it's going to be 4 is greater than 5. You can just think about it. Is 4 greater than 5? No, so 4 is not a solution. Or you can look at the number line. 4 in this line would be somewhere to the left of 5. And as you can see, it is not on the line, so it's not a solution. Now let's go into solving these inequalities. And how you would solve inequalities is really simple. you just imagine this is an equal sign and solve it normally. How we would solve this if it was an equal question would be to move 5 this way by subtracting -5 from both sides. That would give us 2x, 5's cancel out, equals, let's put dots instead of equals, 9 minus 5, it's going to be 4. And then we would just divide each side by 2 to get rid of this, and be left with x. 4 divided by 2 is 2. And then you can just carry the sign that was in the question before we put the x in, which is less than, and you would get the answer. So if you're solving inequalities, just imagine this as equal to, solve it that way, and then just put the sign in. Now let's do an exception. Let's do this as if you were doing any other question. Move 5 by subtracting 5 from both sides. It's going to cross this out. -x, leave a space. -10 minus 5, it's going to be 15. And then we have to get rid of this negative sign because we want to leave x in. So I can just multiply it by -1. Because when you multiply two negatives, you get a positive. So you can just multiply both sides by -1 or divide both sides by -1. It's going to be the same thing. And we would get x 15. Now, if we were doing this the way we did this question, we would just move this sign down and say greater than or equal to. But this is the rule with inequalities. If we multiply or divide by a negative number, we have to flip the sign. So instead of saying greater than or equal to, we say less than or equal to. Now let's see why we do this. Let's put a number in. So we solved this to be x is less than or equal to 15. But let's say we didn't flip the sign and we did it wrong. We would get this if we didn't follow the rule and just use the same sign. Now let's plug a number in for x. Let's say 2. When we plug 2 in the original equation, we get 5 minus 2, which is 3, greater than or equal to -10. And this is true because 3 is greater than -10. But if we plug 2 into this equation that should be the solution, we get 2 is greater than 15, which is not true. So we have to flip the sign like we did when solving it. The rule is if you multiply or divide by a negative number, you flip the sign. All right, now let's get into domain and range. Domain and range are going to be shown by inequalities. Domain is going to be the x. Domain. And range is going to be the y. Now what does that mean? Let's say we have a graph. And let's say it goes like this. If our domain x is given as x is greater than 3, then we need to find 3. Let's say 1, 2, 3. Let's say this is 3. It will be what comes after 3. The x's that are greater than 3 would be our graph. So we will get rid of anything that is before 3. And this would be our graph. Now let's do range. If our range is given as y is less than 0, we would look at y and find 0, which is here. And if this says y is less than 0, that means all the y values we want to look at are less than 0. So we would get rid of all of this. And this, what's left, would be x is greater than 3 and y is less than 0, the domain and range. Now, sometimes the question gives us two equations. Let's look at linear equations because we did those the previous class. 3x plus 1 and y equals 4x plus 2. And the question might say, this is true for x is greater than 3, and this is true for x is less than or equal to 3. What this would mean is that we would graph this for any number of x that is greater than 3 and graph this for any number that is less than 3. Now let's see what that means using the graph. Now I want to start by graphing both. Let's graph these the way we learned in the previous class. You would first find the y-intercept. In this case, for this, it's 1. And then you would just go rise over run, which in this case is 3. So 3 units up, 1, 2, 3, 1, 2, 3, and 1 unit to the right. So our point is here. And then 3 units up again, 1, 2, 3, and 1 unit to the right. So our line would be something like this. Now let's graph the second one. And before we forget, this is going to be 1, 2. 4x plus 2. Our y-intercept is going to be here. 4x is going to be 1, 2, 3, 4, 1 unit to the right. 1, 2, 3, 4, 1 unit to the right. And that's going to be something like this. Now, we know that wherever x is greater than 3, it's going to be this, which is the pinkish graph. That is not the right color. I'm just going to replace that. Okay. So x is greater than 3 is going to be this colored one, and x is less than or equal to 3 is going to be the blue colored one. Let's see. 3 would be 1, 2, 3 here. Anything bigger than 3, anything larger than 3, all of this is going to be the pink graph. So if we draw a line like this, we can just have the pink line keep going, and we can just end the blue line at 3. Anything less than 3 is going to be the blue line, so we can just get rid of all the pink line anywhere less than 3 and continue the blue line. So our graph would be something like this. And they would separate at 3. Now let's move on to graphing these inequalities. And these are also going to be really simple. So, the way we graph this is to imagine it was a linear equation first. Imagine this is an equal sign, like we did when we were solving it. If this was an equal sign, we would graph it the way we graph a linear equation. We would first find the y-intercept, 1, 2, 3. That's our first point. And just do rise over run, 3 over 2. So 3 up, 1, 2, 3. 2 to the right, 1, 2. That's our second point. 3 up, 1, 2, 3. 1 to the right. That is our line. We can just graph this side too. 1, 2, 3. 1, 2. That's our other point. 1, 2, 3. 1, 2. Another point. All right. I'm just gonna go all the way to the end. All right. Let's say this is our line. We graph the linear equation. And then how we would incorporate the sign is first to look at if it's equal to or not. In this case, it is less than or equal to. When we say or equal to, we keep the line like this. If it was just less than, then we would break up the line and make it dotted like this. But because in this case it is less than or equal to, if it has the line under it, we're going to have our line completely filled in like this. And then we look at this part of the sign. In this case, it is less than. So we're going to shade in one part of the graph. It's either going to be shaded in like this, or it's going to be shaded in like this. Let's just put the graph in again. It doesn't have to be exact right now for this question. So how we find which side we're going to shade is to plug in points. Let's plug in this point to see if it fits in the equation. This point is going to be first the x value, which is 1, 2, 3, 4, 5, and then the y value, which is, in this case, 0. Now let's plug this into the equation. Y is 0, less than or equal to 3 over 2. X is going to be 5 plus 3. And then you just solve this. 0 less than or equal to 3 over 2 times 5 is going to be 15 over 2 plus 3. Now, is 15 over 2 plus 3 less than or greater than 0? It is greater than 0. And the equation says 0 is less than this number, which is true. Because this is true, and our point is over here, we would shade this side of the line. And this would be our answer. So, let's review before we do another example. We first graph it like we would graph a linear equation. Then we look at the sign. If it says greater than or equal to or less than or equal to, the line is going to be a full straight line. If it is less than or greater than, and it doesn't have that line under it, then we break the line up like this and have it dotted. In this case, it is less than or equal to, so we have a full line. And then we just shade in one side of the graph. And how we do this is plugging in points to the original equation and solving them to see if it's right or not. Okay, let's do another example. Y is greater than 3x plus 5. One is to graph this as a linear equation. First, let's find 5. 1, 2, 3, 4, 5. Then 3x. 1, 2, 3. 1 this side. 1, 2, 3. 2, 3. And then we graph it. Second step is to see if it is dotted or if it's a full line like this. Now, this is just greater than. It's not or equal to. So we have to have our line dotted. And how we do that is just like this. It's going to be our dotted line. And then we need to figure out which side of this graph we're going to shade. In order to do that, let's choose an easy point. Let's choose this one. That's just 1, 1. That means y is 1 and x is 1. So we rewrite this with that plot point and just solve. 3 times 1 is going to be 3, plus 5 is going to be 8. So when we plug the numbers in, we get 1 is greater than 8. Now 1 is not greater than 8, so this is not correct. So we don't shade in this side, we shade in this side. And that's our answer. Now let's go into system of equations. And this is going to have 3 different types we need to learn. Now, when we say system of equations, we're talking about 2 different equations we're given. For example, y equals 3x plus 1 and y equals 3x plus 5, let's say. And system of equations is asking us for a solution. It's asking us what we get when we have both lines. And this is going to make more sense when we get into the 3 types of ways we can solve this. But let's just learn the types of answers we can get. The first answer we can get is no solution. Sometimes there are no solutions, and we would get this when the 2 lines never meet. For example, when they're parallel, there's no point where these two lines are going to intersect. So that would be no solution. The second answer we can get is one solution, or in some cases two solutions, like actual solutions. And that would mean our lines intersect at one or few points. For example, this would mean our lines intersect at 1 point. Our lines can also intersect in 2 points. For example, if we have something like this, a parabola that we're going to get into in the later lessons, in a linear line, our lines are going to meet in 2 places, and that would be 2 solutions. And the third type of solution we can get is all real numbers, which would mean every single number is a solution. And the only way we can get this is if both of these lines are the same thing, if they are on top of each other. And that would be our third solution. So let's go into how to use each type of way to solve system of equations. Let's start with graphing. Graphing is what you would expect. We graph the solutions to see where they intersect, which is going to be the answer to our solution. We make a graph. We have our lines. Let's make it easy. Y equals 3, and let's say x equals 4. Y equals 3 is going to be where y is 3. 1, 2, 3. So that would be a y equals 3 line. X equals 4 is going to be where x equals 4. So we find x, 1, 2, 3, 4. And that's our line. So that goes through 4. And the solution would be where they intersect, which is right here. So in this case, we have one solution, and it is here, which is 1, 2, 3. Y is 3. X is 1, 2, 3, 4. X is 4. Now let's talk about substitution. That's going to be when we substitute a letter for another equation. What do we mean by that? Let's say our lines are y equals 2x plus 2 and y equals 3x plus 1. Now, as you can see, both lines have an y and an x. So we can just substitute this y for this y, which is equal to this. So we can just take this whole thing, and plug that in as y, because we know y is equal to this number, whatever this is when we plug the x in. So we can just say 3x plus 1 instead of y equals, just carry this down, 2x plus 2. And then we can just solve this. Minus 2x on both sides. That's going to be x. Just carry the plus 1 down, equals, these cancel out, 2. And then just minus 1 on both sides, which gives us x is equal to, these cancel out, 2 minus 1 is going to be 1. X is 1. So we got the x coordinate of our answer. Now we need to find the y coordinate. And to do that, we can just plug this one in, plug the 1 in as x in any one of these. Let's plug them for this one. 2 times 1 is going to be 2, plus 2 is going to be 4. So we know at 1, y is 4. That's our answer. With elimination, we're going to look at something like this. Let's say y equals 2x plus 1 and y equals negative 2x plus 1. Or just have a different number. Negative 2x plus 5. We use elimination when there's a coefficient that is the opposite sign of the same number. For example, in this case, it's 2x and negative 2x. When they have the opposite number and the opposite sign and the same number, then we can use elimination. And this is going to be really easy. We're just going to eliminate this. 2 and negative 2, they're going to cancel out. The x is 2. This is going to cancel out. Then we're just going to add these two together. Y plus y is going to give us 2y equals 1 plus 5 is going to give us 6. And then you can just divide both sides by 2 and get 2y equals 3. And that's your y. In order to find x, you're just going to plug y into one of the equations like we did with substitution. Let's plug it into the first one. 3 equals 2x plus 1 minus 1 on both sides. 3 minus 1 is going to give us 2. Carry 2x down. 1s are going to cancel out. And then you can just divide both sides by 2. And then you get x equals 2 divided by 2 is going to be 1. So our answer is the x is 1. All right, let's do one last example. We have negative 12x plus 9y equals 7 and 3x minus 4y equals 2. Now just to learn how to do the other way, I just want to change this to plus 4y. Let's do this question instead. Now, as you can see, we have the same number but the opposite signs. So we can just cancel these two out. We can use the elimination method. When we cancel these out, we can just draw a line. Negative 12x plus 3x is going to give us negative 9x. These canceled out equals 7 plus 2 is going to give us 9. Divide both sides by negative 9. And we get x equals 9 divided by negative 9 is going to be, because they have different signs, negative 1. That's going to be our x value. And then we can just plug this back into any one of these equations to find y. Let's plug it into this one. 3x is negative 1 minus 4y is equal to 2. 3 times negative 1 is going to be negative 3. You can just carry the negative 4y down and equals 2. Negative 3, in order to carry this to the other side, just going to do plus 3, plus 3. That's going to give us negative 4y, because these two cancel out. 2 plus 3 is going to give us 5. And then you can just divide both sides by negative 4, and you'll get 5 over negative 4 for y. And in order to answer this question, our x value is going to be negative 1. Our y value is going to be 5 over negative 4. And that's how you use the elimination method to answer some of equations question. All right, that's it for today. Thanks for watching. In the next lesson, we're going to take a little bit of a break from graphing, and we're going to learn about units, rate, percent decimals, and sales, etc. questions. Thank you for watching, and I'll see you guys in the next lesson.